Okay, number one, they give you x times the square root of 4x minus 1. They want us to find f prime of x. To find f prime of x, we have a product rule. So we want to think of this as 1, 2, 3, 4. So it's going to be first times the derivative of the second. So we want to think of the second as 4x minus 1 to the 1/2. So when we derive that, it's 1/2. Keep it. Drop it by 1, so 1/2 goes to negative 1/2. And then the derivative through the chain rule is times 4. On the other side, the derivative of x is 1. And we keep the square root, 4x minus 1. So we want to simplify this a little bit. Over here, 4 times x is 4x. On the bottom we have 2, and this whole square root drops down because it's a negative exponent. So the square root of 4x minus 1 plus, on the other side, 1 times this stays. So we have 4x minus 1 over 1, which is the correct answer, but now we need to look at the multiple choice, see what they give us. To find the one they're looking for, first thing you want to do is take this 2 and this 4 and cancel, and then we need a common denominator. So the part on the right needs another square root of 4x minus 1. So if I do that on the bottom, I do it on the top. Now it has 2 of them. When I square that square root, it frees it up. So I have 2x plus 4x minus 1 all over square root 4x minus 1. Combine up top, 2x and 4x is 6x minus 1 over the square root of 4x minus 1. Number 2 asks for the area between y equals x to the third and y equals negative x minus 1 over 0 to 2. So this is a top curve minus bottom curve question. They're to give us the bounds of 0 to 2. So we want to say which one would be the top curve. Well, if I plug in 2 to the third's 8, 2 over here is not going to be as high as that number. So the top one would be x to the third, and we can say minus negative x minus 1. So another way of saying top curve minus bottom curve, you can combine it all under one integral. So as we have it right here, and then do a little subtraction. So this is x to the third minus minus makes a plus, minus minus makes a plus, and these are all dx. So when we integrate, this is x to the 4th over 4 plus x squared over 2 plus x from 0 to 2. If I plug in 2 to the 4th is 16. 16 divided by 4 is 4. 2 squared is 4. 4 over 2 is 2. We plug in 2. Subtract the other one, which gives us 0. Final answer, 8. Number 3 gives you a second derivative, and it asks for the points of inflection. You can see from the second derivative, our test points are going to be at 1, negative 2, and 4. Now you want to pick a test value on all sides. So I'm going to try 10, 2, 0, and negative 10. To have a point of inflection, you have to have a sign change occur from the left to the right. So if I rewrite this as x minus 1, x plus 2 to the third, x minus 4 squared. Now I try my test values. I don't really care what the answer is, but I want to know if it's positive or negative. So if we start with negative 10, if I plug it into this quantity, negative 10 minus 1 gives me a negative. If I plug negative 10 into here, I have a negative, and negative 10 into this one is negative 14, but squared makes this a positive. Negative times a negative is a positive, times a positive is a positive. Plugging in 0 would give me a negative, positive, negative 4, but squared is positive. Negative times positive is negative, times positive gives me a negative. Plugging in 2, 2 minus 1, positive, positive, positive. and plugging in 10. Positive, positive, positive. So when you look at the sign chart, there is a sign change here, positive to negative. That makes a point of inflection for -2. And there's also a sign change surrounding that one. There is not a sign change there, so my points of inflection are at -2 and at 1. Number 4 gives you a function, asks you to find f prime of -1. So before we can plug in -1, we need to find a derivative. And before we can find a derivative, I want to rewrite my original. So -x to the 5th plus x to the -2. Now I want to find a derivative. So f prime of x is equal to -5x to the 4th plus 1 minus 2x. I'm taking the derivative, so I want to decrease this. So this is to the -3rd. Now I want to plug in -1. So f prime of -1 is equal to now we want to do some evaluating. -1 to the 4th is 1. So this is -5 plus 1. Over here, we want to rewrite this. -1 to the -3rd is a -1. So this is really, when you flip it, -2 over -1, but a negative and a negative make a positive. -5 plus 1 plus 2 is really -5 plus 3, -2. Number 5 says capital letter F of x is equal to the integral of 1 to x squared. And you'll see now to the right we have t's with dt. So it asks us to find the derivative f prime, capital letter F prime, and then plug in 2. So the first thing we want to do is just find f prime. So f prime is going to be when we have x's with t's, when we derive, we want to get rid of all this and just plug in the top bound. When you plug in the top bound, x squared squared is x to the 4th plus 3, and you need to multiply through by the chain rule. So f prime is 2x times the radical of x to the 4th plus 3, and the problem asks us to plug in a 2. So f prime of 2 is equal to 4. When I plug in 2 here, 2 to the 4th is 16. 16 plus 3, 19. Number 6 asks you to estimate the total number of gallons of cola that were produced in a day. In other words, this question asks you to estimate the area under the curve. So if you look at the picture for number 6 that's given, I see 1, 2, 3, 4, 5, 6 boxes. So if we do the bottom row from 0 to 2400, or to 24 rather, 0 to 24 and then up 100. So I have 24 by 100. The bottom 4 is 2400. Above that there are 2 more boxes. Each one of those is 6 by 100 and then 6 by 100, so we have 1200 here. And then we essentially have 1, 2, 3, 4 triangles, and each triangle approximately gives you 300. So we have 2400 and 1200 is 3600, and 4 more sets of 300 give you a total of 4,800. Number 7 asks to find the average value from 0 to 2 for the given function. First thing we need to know is that average value is 1 over b minus a, so in this case 2 minus 0 is 2, times the result of the integral when you integrate the following. So to integrate this, we need a u substitution. So this is the integral of x to the 3rd, and we're going to let u be equal to x to the 4th plus 9, so that du would be 4x to the 3rd dx, which would then make dx equal to du over 4x to the 3rd. And when we plug this in now, this is going to be to the 1/2. Now this is our u, and then du over 4x to the 3rd the x to the third with this x to the third cancel, and we need to pull out a 4, but it's a 4 on the bottom, so I'm pulling out 1/4. But when I pull out 1/4 and there's already 1/2 out here, it turns to 1/8 u to the 1/2 du. So now we integrate u to the 1/2. When you integrate, is going to be u to the 3/2 over 3/2. Don't forget there's a 1/8 coming down. Again, this is all from 0 to 2. So along the way here, these were 0 to 2s. We need to flip this, so it's 1/8 times 2/3 u to the 3/2. We can multiply straight across. This is 2 over 24, and 2 over 24 is 1/12 u to the 3/2, and u is x to the 4th plus 9, x to the 4th plus 9. Again, we're doing this from 0 to 2. So let me draw a line here to separate. So we want to plug in 2 and we want to plug in 0 into 1/12 x to the 4th plus 9 to the 3/2. So a lot of mental math. Plugging 2 into this, 2 to the 4th is 16. 16 and 9 is 25. We want to take this 25 to the 3/2 power. Remember, this is power over root. So again, we have 25. Always do the root first if you're doing it in your head. So the square root of 25 is 5. 5 to the 3rd is 125. So this is 125 over 12. And then we want to plug in the 0. 0 to the 4th is 0. 0 plus 9 is 9. 9 to the 3/2. Again, you want to do the root first. So the square root of 9 is 3. 3 to the 3rd is 27. So this is 27 over 12. Nice that we have a common denominator, so you can go ahead and subtract. 125 minus 27 is 98 over 12. And if you look at your multiple choice answers, they simplified this by dividing the top and bottom by 2, giving you 49 over 6. Number 8 asks us to integrate from 1 to e squared for the given function. The strategy here is to split these into 2. So x to the 3rd over x is x squared, and then this is 1 over x, again from 1 to e squared. When I integrate x squared, I have x to the 3rd over 3. When I integrate 1 over x is the natural log of x, and we're running this from 1 to e squared. If I plug in e squared to the 3rd is e to the 6th over 3, plus when I plug in e squared into here, natural log of e squared. Remember, we want to think of this as log base e. So if I plug in e squared, this is e to what power is e squared? And that would be 2. Now we want to plug in 1. 1 to the 3rd is 1. So this is 1/3. When I plug in 1 here, natural log of 1. Again, log e, but now to 1. So e to what power is 1? 0. So this is e to the 6th over 3. And I want to put this 2 over 3, so I'm going to make it plus 6 over 3 minus 1 over 3. Gives us e to the 6th over 3 plus 5/3. Number 9 gives you the graph of f of x from 0 to 4. And it says, which of the following could be the graph of f prime? So we have the graph of f, and we want to know which one could be the graph of its derivative. So if I have the graph of f, I see from 0 to 2 this is decreasing. So for the derivative, that would mean it's below the x. And then from 2 to 4, it's increasing. That means it's above the x from 2 to 4. So looking at these pictures, A does not do that. B does not do that. So now I'm looking at C, D, and E. Again, I want it to be below the x from 0 to 2. Does not look like E does that. So now I'm down to C or D. Okay, so I look back at number 9 and I say it looks like it might have a point of inflection right here and right here. Because if this graph had kept going, such as this, there was a turn there and a turn there. So it looks like the points of inflection would be somewhere around 1 and somewhere around 3. So if we were to say that those are points of inflection in the derivative, that would be a turning point. So if we compare C to D, only one of them have turning points at those spots that we just picked out. So the graph approximately of f prime of x would be choice D. Number 10 is a mean value theorem question. So before we get into the problem, the mean value theorem is f prime of C is equal to f of B minus f of A over B minus A. And again, this is saying that the slope of the tangent line will be equal to the slope of the secant line. So in the question for number 10, it says the function f is equal to, so f of x is equal to 2x to the third minus 4x squared plus 1. It says the application of the mean value theorem to f on the interval from 1 to 3, 1 to 3, guarantees the existence of a value c where from 1 to c to 3, f prime of c is equal to. In other words, it's just asking you to solve the right side of the equation. So to find f of b minus f of a over b minus a, we just want to plug in the endpoints. So I want to plug in 3, I want to plug in 1, and then it's going to be divided by 3 minus 1. So if I plug in 3 to the third is 27, doubled is 54. 54 minus 9, 36 is 18, and 18 and 1 is 19. Plugging in 1, I have 2 minus 4 plus 1, so minus a negative 1 gives me 20 over 2, and that gives me 10, choice C. Question 11 asks you to find the equation for the tangent line at x equals negative 1. If you want a tangent line, you need a point and you need a tangent slope. So you need a point and you need a tangent slope. The point they give you is x is negative 1. So you have negative 1. To find the y part of that point, you want to plug in negative 1 into the equation. So where do I plug into for x, right? So if I plug negative 1 in up there, my integral is going from negative 1 to negative 1. In other words, I didn't go anywhere. So that whole integral is 0, and then 3 minus 0 is going to be 3. So the y coordinate is 3. Now I want to find the tangent line, so I need the derivative. So I'm looking for y prime. So when I do y prime, the first thing I notice is this 3 is going to go away. So now I have a negative symbol. Now, the trick to this actually is keeping the negative symbol. Because you notice we have x's and t's. So this is one of those, so forget about the 3. The 3 is now gone. So if I wanted to integrate this, when you have your x's and t's, remember how we cross everything out and just plug in the top bound? Now the top bound is a nice one because you don't need a chain rule, right? X goes to 1. So in other words, I just want to plug in x up there, but you have to remember that there is a negative symbol out front is the trick to this problem. So if I plug that in, you really have negative e to the negative x to the third. Okay? And then what am I plugging in? What value for x? Negative 1. So this is negative e to the negative 1 to the third. Notice this negative is already out there. And then I plug in negative 1. Okay? Negative 1 to the third is negative 1, but then another negative makes that, so it's just negative e. M prime is negative e. That's really, really, really tricky. There's a lot of symbols there. Now you have a point, now you have a slope. The rest is easy. Y minus y1 is equal to mx minus minus is a plus, and that gives you choice B. Number 12. The limit as h approaches 0, all this stuff. We want to recognize that this problem essentially says this. F of x is equal to sine x, and they're asking you to find the derivative and plug in pi over 3. So this whole thing up here, this whole limit question is just a whole other way of saying take the derivative of whatever right here and then plug in the pi over 3. So we know the derivative of this Sine goes to cosine, and then we want the cosine at pi over 3. Pi over 3 is 60 degrees, so at cosine of pi over 3, we should be at 1/2. Number 13, they say the integral from a to b, g of x, they give you a result for g of x. They tell you it's 4a plus b. Then they ask you, what would the result be of that same thing but plus 7? Well, we already know the part here that I just underlined. So if I split this into two integrals, this is the integral of g of x plus the integral of 7. Again, from a to b, from a to b. And these are both dx. We know this one's result right here. If I integrate this, they tell me the result. This one right here, when I integrate, is 4a plus b. And then what are we doing? We're adding the result of this one. Well, what do I get if I integrate 7? Again, these are both dx's. If I integrate 7, 7 would be what? 7x from b to a. So what do we do? Plug in b, so that's 7b minus 7a. Now we combine our like terms. 4a minus 7a is negative 3a, and b and 7b is 8b minus 3a. All right, 14 asks you to find the integral from negative 3 to 5 of f of x. And the thing you need to realize is that the graph that I'm holding up here, the graph they give you, is the graph of f of x. So you have f, and they ask you to find the area under f. So your letters match. In other words, you just want to find the area of the shapes. So the areas underneath are going to be negative. The areas above are going to be positive. So the first area you have is a triangle that looks like that. Underneath, it's 2 over, 2 down. 2 times 2 is 4. Cut in half because it's the area of a triangle. Gives you 2, but it's under the axis, so it's negative 2. The next thing under is a box going from negative 1 to positive 1, and then down 2. So its dimensions are 2 by 2. Which is 4, but it's negative. And then you have a triangle also below that's 1 over, 2 down, cut in half, negative 1. And then above, we have a triangle that is 1, 2, it's 3 over and 4 up. So that's 12. Cut in half is 6. So there's your areas right there. It's what, 7 underneath and 6 above, giving you a result of negative 1. Okay, 15. It says f is continuous for a to b, but not differentiable for some c that is between a and b. So if you make a quick sketch of what this just said, it says some function f is continuous from a to b. So here's a, here's b. There is something that's continuous from a to b. And then it says there's a c somewhere in between these such that c is not differentiable in between these two. And then they give you choices that say what could cause this thing here to not be differentiable, but it's still continuous. Okay? X equals c is a vertical asymptote. If this was a vertical asymptote, this would be a dotted line cutting through. It would definitely make it not differentiable, but it would no longer be continuous, right? Second one, limit as x approaches c, f of x does not equal f of c. Well, that's the definition, rule number 3 for continuity. That doesn't work. The third one, cusp is the same thing as sharp point. So if I was to draw this as from A to B, and here's my C, if I said that is still continuous, but it's not differentiable. So the choice you're looking for in number 15 is choice C. Okay, number 16 says y is equal to sine x cos x. Find dy dx, also known as the derivative at pi over 3. So to find the derivative, you have a quotient, or not quotient, you have a product rule, first times the second. So I want to say 1, 2, 3, 4. So sine, and then the derivative of cosine is negative sine, and then going the other way, keep the cosine, and then we have another one. Combining is negative sine squared x plus cosine squared x. I'm going to rewrite these just because I like my first term positive. So I'm going to say cosine squared x minus sine squared x. And then keep in mind that this really means cosine of x quantity squared minus sine of x quantity squared. And what I'm plugging in for x in the derivative is pi over 3. So this is cosine of pi over 3. And I square it, minus sine pi over 3, and square that. So at pi over 3, we're at 60 degrees. So the cosine at pi over 3 is 1/2. 1/2 squared is 1/4 minus the sine of pi over 3 is root 3 over 2. And when you square root 3 over 2, you get 3 over 4. 1/4 minus 3 over 4 is negative 2 over 4, negative 1/2. Okay, for 17, it gives you the formula or the equation for velocity v of t. It says v of t is equal to 2 cosine 3t. Wants to know the distance traveled. If you want to know the distance traveled and you have velocity, you want to integrate, whether it's a graph or an equation. If you integrate velocity time, you end up with distance. So it says find the distance, so integrate my velocity, but now what's it say? It says from 0 to the first time it stops. So how do you find when it stopped? You want to set the velocity equal to 0. Okay. So I'm going to divide both sides by 2. And now I want to, it's kind of a trick, you just cover up the angle, and I say to myself, where is cosine equal to 0? It's at pi over 2. At pi over 2, and then you bring down the angle. Okay?
What happens at 2?
So I divide both sides by 2, and when I divide that by 2, I can divide the 0 by 2, and it just stays at 0. Okay? So now I have 3t is equal to pi over 2. Divide both sides by 3, and t is equal to pi over 6. So that is the top bound that I was looking for. That's the first time it stopped. So now I want to find the distance traveled. So I want to integrate from 0 to pi over 6 to cosine 3t. And I'm going to take the 2 and pull it out because it's a constant. Okay, so now I want to integrate this, so I'm going to need a u substitution. So I say let u be 3t. That makes du 3 dt, which makes dt du over 3. Plugging in now, I have 2, still the same integral from 0 to pi over 6, cosine u du over 3. So I'm pulling out not a 3, I'm pulling out a 1/3, but there's already a 2 out front. So now I'm going to have 2/3 integral cosine u du from 0 to pi over 6. Integrating cosine gives me sine. So this is 2/3 sine u, but what is u? 3t from 0 to pi over 6. Get some more paper here. So I want to plug in pi over 6. So 2/3 sine, so it's 3 times that. So 3 pi over 6 is really pi over 2, minus 2/3 sine 3t, if I plug in 0, is just sine of 0. Sine of pi over 2 is 1. 1 times 2/3 is 2/3. Sine of 0 is 0. Final answer, 2/3. Number 18 says the limit as x approaches -3 of x squared minus 9 over x squared minus 2x minus 15. When you do a limit, you always hope that you can plug something in, but if it makes the bottom 0, then you can't do that. If we plug -3 into the bottom, -3 squared is 9. 9 minus a -6 is plus. That's really 15 minus 15, so you cannot just plug in. So now we say, hopefully we can factor. So that's x plus 3, x minus 3. And then on the bottom we have x and x. We want a -2 in the middle. So minus 5 plus 3. Now I'm going to cancel the x plus 3 with the x plus 3, and I'm going to try plugging in negative 3 again. If I plug negative 3 in this time, negative 3 minus 3 is negative 6. Negative 3 minus 5 is negative 8. Negative over negative is a positive. Positive 3/4. 19 asks us to integrate. You want to split this into two integrals. So I want to write this as, I'm going to pull the constant out, 5 integral e to the 2x plus integral 1 over x. These are both dx at the end. So on the left, you need a u substitution. So I'm going to say let u equal 2x. So du is 2 dx. So dx is du over 2. Taking this and coming back up top is 5 integral e to the u du over 2. The 2 on the bottom means 1/2. So when I pull out the 1/2, I already have a 5 out front. So now I have 5/2. And then e to the u du. E to the u goes, when you integrate, it stays e to the u. And u is 2x. Plus, when you integrate 1 over x, you end up with natural log x. And then there is no bounds in this problem, so plus c. You'll notice in the answer choice, a lot of times they use absolute value symbols with natural log because you can't raise e to anything and get a negative number. Final answer, 5/2 e to the 2x plus natural log of x in absolute value symbols plus c. Number 20 says the graph of the function shown is f. Which of the following statements about f is true? We're looking for something that is true. Choice A is the limit for A the same as the limit for B. That's definitely not true. And if you look at B, hopefully you recognize right away that B doesn't have a limit, right? Because to have a limit, the limit from the left has to match the limit from the right. So A definitely can't work. I'm looking at B. Does the limit at A come out to be 4? And the answer to that is yes, because when you approach a hole in the graph, you can approach it from either side. And in this case, the limit at A coming from the left and coming from the right is 4. Choice B is the correct answer. Okay, 21 and 22 is a two-part problem. They give you the following graph. The first one for 21, it says, at what value of t does the spider change direction? You have a graph of velocity, and we learned that whenever it is at 0 is whenever you would be changing directions. So in this case, you would be looking for 4, choice B. For 22, it says, what's the total distance traveled? So we said when you're doing one of these with total distance, you disregard the negative numbers underneath. So you want to find the area under the curve from 0 to 8. And when you do that, you want to find the area of each shape individually. So triangle, 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 and then a rectangle from 5 to 7. You should be coming up with C, 9. For number 23, they give you y is equal to cosine 3x. Asks you to find the tangent line at x is equal to pi over 6. To find a tangent line, you need a point and a slope. My point is at pi over 6, comma. To find the y value, you plug in x. If I plug in pi over 6, 3 pi over 6 is really pi over 2. Cosine at pi over 2 is 0. And then I want to find my tangent slope. To find my tangent slope, I need a derivative. So y prime. So cosine 3x, its derivative would be negative 3 sine 3x, because cosine goes to negative sine. I'm going to plug in pi over 6. So this is negative 3 sine of 3 pi over 6, which is pi over 2. Sine at pi over 2 is 1 times negative 3, negative 3. So y minus 0 is equal to negative 3x minus pi over 6. And that looks like choice C. Okay, number 24 says, let f be the function defined above where c is a constant. For what value of c, if any, is f continuous at x equals 2? So if we want this to be continuous, that means we want it to be the same. And I'm letting x be equal to 2, right? Because you see that for x less than 2 and for x greater than or equal to 2. So if I write these as x being 2, this would be 2 squared, which is 4. So 4 sine of 2 pi. And if I want them to be continuous, that means I need to set them equal to each other and see if we can find something. So again, we're letting x be equal to 2. So that's 4 plus 2c minus 18. Okay, and what do we know about the left now? Sine of 2 pi. 2 pi for sine would be 0. So this is 4 times 0, which is 0, is equal to 4 plus 2c minus 18. 0 is equal to 4 minus 18 is negative 14 plus 2c. Add the 14 over. 14 is equal to 2c. c is equal to 7. Does that answer make sense? If I was to plug that back in, we just proved by saying them equal, it would make this one equal to that one, which is what you would need for continuity. Number 25, they give you y is equal to x squared plus 2, and they give you y is equal to 11. It asks for the area of the region enclosed. They do not give you any bounds. So to find the bounds, you set the equations equal to each other. Subtract 2, and you get 9. Square root both sides. X is equal to plus and minus 3. So now I know I have the integral from negative 3 to 3. And this is top curve minus bottom curve. The top curve is the line of 11. The bottom curve is x squared plus 2. So 11 minus, in parentheses, x squared plus 2. Doing some more math is 11 minus x squared minus 2. And we can still say that this is 11 minus 2 is the integral of 9 minus x squared from negative 3 to 3. When you integrate this, 9 goes to 9x minus x to the third over 3. So we have 9x minus x to the third over 3 from negative 3 to 3. If we plug in 3, this is 27 minus 27 over 3 is 9 minus plugging in negative 3. It would be negative 27. This is going to be a minus minus, giving us a plus. First one is 27 minus 9 is 18 minus negative 18. Minus minus is a plus. Answer is 36. Okay, number 26 asks us to integrate from pi over 4 to pi over 2. So a lot of things going on. Typically when you see a trig function in the bottom, you want to try to find a way to flip it and bring it to the top. So I'm going to rewrite this as the integral. If I flip sine squared, I really have cosecant squared and then negative e to the cotangent x dx. So if we let u be cotangent x, that would make du negative cosecant squared x dx, which makes dx du over negative cosecant squared x. So when we do that up here, notice there's a negative with the e, and then I'm about to put another negative down underneath. So this is the integral of cosecant squared x negative e to the u du over negative cosecant squared x. So the cosecant squared x's are going to go. And I could pull out this negative, but I'd also pull out that negative. So if I pull out two negatives, those are also gone because you would just have a positive. So now I really just have the integral of e to the u du, which is e to the u, which is e to the cotangent x from pi over 2 to pi over 4. Okay, so this is really e to the cotangent of pi over 2 minus e to the cotangent of pi over 4. Cotangent of pi over 2 is at 90 degrees, so that's really cotangent of pi over 2 would be 0. So e to the 0 minus cotangent of pi over 4 is 1, so minus e to the 1. Anything to the 0 is 1, so this is 1 minus e. Okay, for number 27, they want you to find dy dx. It's an implicit differentiation problem. They tell us x is 1. First thing I want to do is find y, so I'm going to plug in 1 for x. Doing that would give me 1 plus 2y minus 4y is equal to 7. 1 minus 2y is equal to 7. Negative 2y is equal to 6. Y is equal to negative 3. So now I have 1 comma negative 3. I'm going to go back to the beginning now and find our derivative. This one was the second derivative, so let's find the first one. 3x squared plus product rule minus 4 dy dx is equal to 0. Product rule. First is 2x squared times the derivative of the second, so dy dx. Oh, I put too many things here, huh? Just scratch those out. And then plus, doing it the other way around would be 4xy. So let me rewrite this. We have 3x squared plus 2x squared dy dx plus 4xy minus 4 dy dx is equal to 0. Anything with the dy dx stays on the left. Everything else goes to the right. So 2x squared dy dx plus minus 4 dy dx is equal to negative 3x squared. What else do we got? Minus 4xy. And we're going to be dividing that by 2x squared minus 4. Into this, we want to plug our 1 and our negative 3. So if we plug those in, what do we get? If I plug in 1, that's negative 3 minus minus, so plus. Negative 3 plus 12 is 9. And what do we got? 1, negative 2. Oh, I'm sorry, I was looking at number 28. This is not the second derivative. 27 just asks for dy dx. So we're done right now. Negative 9 over 2, choice A. If it asks for the second derivative, you'd keep going. 28 is the one with the second derivative. Is that good? Okay. Question 28 asks you to find the second derivative at the point 3 comma 4. The first thing I did is rewrite this as x squared plus y squared is equal to 25. From there, I'm going to differentiate implicitly. 2x plus 2y, anything with a y gets dy dx, is equal to 0. We want to solve for dy dx. Dy dx is equal to, so we'd pull the 2x over and make it negative and divide by 2y. So this would be negative 2x over 2y, so negative x over y. And then if we plug in the points that they gave us, we know that dy dx will be equal to negative 3 over 4. The problem asks, though, for the second derivative. So to take the second derivative, you need to take the derivative of the first derivative. To do that, you need a quotient rule. Bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. Simplifying is negative y minus a negative x, so plus x dy dx over y squared. So what do we know? Y is 4, so this is negative 4 plus 3. We know dy dx is negative 3/4 over y squared. 4 squared is 16. This is negative 4, and I'm going to put it over 1, minus 9/4 over 16. If I want this to be a 4, I make this a negative 16. Minus 9 is negative 25 over 4 over 16. And when you flip them, final answer, negative 25 over 64.